we'll see. All right, so you guys know that yesterday we started talking about different things that you want to be able to tell apart. And today we're going to look at the second set of those things, which is different types of samples. And again, your book specifically refers to 5, and they are probably the 5 most important types of samples there are. They make it appear that these are cut and dry, and you never see any difference between them. In the real world, they overlap all the time. However, I'm going to try and give you the dead giveaways you can look for in problems to identify what type of sample is which. And we're going to start by talking about convenience samples. So convenience sample, it tells you right here, is a sample that you choose because it's convenient, it's easy. And there are a lot of ways you might encounter convenient samples. Like, for instance, when you do your project, you might say, gee, Mr. Meister, can you pass the survey out in religion class for me? And whoever responds to it, that's your sample. That would be a convenient sample. The same thing happened in the problems you just did about the person that was looking at what kind of pop do people like, so they watch people at the vending machine during break. And, that's probably not going to be the most accurate sample of everything you could possibly get, but it does give you some ideas of what might be going on. So convenient sample is easy, but a lot of times it's not a particularly good sample. However, if you are like doing your project, it's fine. It'll do for what you have to do on it. If you were doing important scientific research, it's not fine. And you do need to kind of think, what is the point of what I'm doing? Obviously, the more important it is, the less you would want to use a convenient sample. There's some different things that would be convenient samples. One of them is like asking friends or coworkers. That's an easy sample to gather. Sometimes you'll see things like somebody might be going around a mall with a clipboard and saying, would you like to take a survey? And that's a convenient sample, both because most people are just going to say no and not bother doing it. And they're probably not even going to go up to people that look threatening. They're just going to totally avoid them and go somewhere else. Another thing that happens a lot these days are what we call self-selected samples. These are things that you see on the internet where you can click here to register your opinion. Or things where you call a phone number or text something to participate in a poll. If you see something that people have selected themselves like that, it's probably not going to be very reliable. That's because there's 2 kinds of people that might participate in that type of a survey. One of them are people that care really, really deeply about whatever the topic's about, like their whole life is about politics. The other would be people that have way too much time on their hands. And they're just bored, and so they're clicking around on the internet all day. And neither of those is probably going to reflect most people, okay? But that would be a convenient sample. So convenient, the whole point is it's easy. Everybody good with that? Second one is what's called a systematic sample. It says ahead of time you have decided on a system for how you're going to choose the sample. And it goes on to say that the most common method by far is somehow numbering off. You guys have all been part of a systematic sample because picture yourself in gym class. And you go 1, 2, 1, 2. Okay, 1's over there, 2's over there, and here's the balls. That's the idea of a systematic sample. Systematic samples, you can kind of tell right off, are going to be a little bit better than just true convenience. But if you picture yourself in PE class, you know that it's really easy to defeat a systematic sample. Because if you know that what you're going to do is number off every day, okay, you get that person you don't like between you and your friend, and everybody's good. And don't tell me you've never done that, but that is going to end up being something that's wrong with that. Sometimes at one point, the TSA, the travel security thing at airports, was taking every 10th person aside for additional screening. Well, if you knew it was like every 10th person they were doing and you were the terrorist, okay, so you get somebody that's clean in that position and you go next. And that would be a really stupid way for them to do things. That's actually, I think, one of your sample questions that's going to come up in a minute, but that is one possibility. Big thing on a systematic sample is before you even began, you've decided who's going to be in the sample and who's not. One way that they'll do systematic samples is like when they call people to do like political polls and that kind of thing. And they'll say, okay, we're going to go through the phone book and call every 50th number in the phone book. Well, the problem if you do that is, Mr. Aronson up at the top of page 1 is never going to be called ever, because you got to go down to the 50th person before you even start. And whoever number 51 is will never be called ever. And same thing with all the rest of those. So before you start who's going to be in it and who's out. It is a little bit better than like just asking your friends, but it's definitely not an ideal sample. Everybody good with those two? Number 3 is a stratified sample. Stratified, the word comes from strata, which you might think of with like rocks that have layers in them. And the idea is we're going to cut through all the layers. That's where this comes from. What you do is before you start, you divide up your population according to some characteristic. Usually when people do like national surveys, that kind of thing, they look at stuff like race or sex, that kind of thing. Doesn't have to be those, but some characteristic you look at and you make sure you divide people up according to that. And then what you make a point of doing is you choose samples from each of those subgroups. So like you make sure that you have chosen women, you've chosen men, you've chosen blacks, whites, Asians, Hispanics, every possible subgroup that you can think of, you have chosen from those. And ideally what you'd want to do is choose those in about the same proportion as the whole population. Something that you will see at school that is a stratified sample is the student council. Because you've got freshmen, sophomores, juniors, and seniors that we choose for student council in approximately the same proportion as the number of students that you have in each class. There's representatives from each of those classes that we choose. And so you can kind of tell that obviously we've made a better attempt to try to include everything here. That is the idea. So you're trying to include variety. But there's always trade-offs in statistics. And it does turn out that just because your sample ends up being good based on what you thought of doesn't mean it's going to reflect things well on everything. And I want to give you an example of that too. One example of a stratified sample that exists in our country is the US Congress. Because in this country, we divide it up into these things called states. And each state gets members of Congress based approximately on the population of those states. So, a big state like California has tons of people in Congress. South Dakota has 3. We have, when you add them up, 6 congressmen and representatives here in Iowa. And so they have made a very definite effort to make sure every state has appropriate representation. The problem is, if you look at Congress, it really doesn't look a whole lot like the whole country. You look at who's in Congress, the vast majority of people in Congress are rich, old, white men. Now, there are, right now, more women than there have ever been in Congress before, but it's still like 20% of Congress that is women. And if you look at like different ethnic groups, you'll find that those are also far less than what the country as a whole is for like blacks and Asians and Hispanics and so forth. Honestly, probably the biggest way that Congress doesn't represent the general public is basically everyone in Congress is extremely rich. It's hard to find anyone in Congress that's not a millionaire, literally. And most people aren't. And so, yeah, they've made an effort to include people from every place, but they haven't necessarily made an effort to include all types of people. And that's, again, an example where, yeah, it works on what they thought of, but then there's other things besides that. But stratified is notably better because you have thought of these different groups. You know, good with that. So next up is a cluster sample, and it tells you here what you do is ahead of time you choose some clusters. In the real world, what cluster sample usually means is you're looking at places. Most common thing you do is you pick like some town or in some other way a place. Your book uses the phrasing they're clusters that are close to each other in time and space. But the most common thing they'll do is find like zip codes and look at numbers for those. That cluster ends up representing everything. Like maybe I want to find out about what are high school kids in America like, and so I look at all the high school kids at Garrigan. Probably not a real good cluster, and kind of a convenient one too, honestly, but it would be one place that ends up representing the whole thing. What I do is I take a census of that cluster. I make sure that I include like every student at Garrigan. And that cluster ends up being my sample. The bottom there mentions that the number one place that cluster sampling is used is in the field of test marketing. Just out of curiosity, any of you guys looking at going to college either at UNI or Iowa or like Kirkwood or Co or one of those places that's in basically the 319 area code? Oh, 3 of you, well, 4 of you, wow. If you're going over to Eastern Iowa for college, you are looking at one of the top 3 test marketplaces in America. If you want to find all the latest stuff before anyone in New York or LA sees it, go to Coral Ridge Mall in Iowa City. And you will find all the coolest stuff right away, way before they have marketed it nationwide. The Cedar Rapids, Iowa City, Waterloo market is a big test market for a couple of reasons. One of them is compared to a lot of the Midwest, that area is more diverse. You do have people of a variety of ages and races over there. There's urban people and rural people. Much more important, though, it's way cheaper to advertise things in Cedar Rapids and Iowa City than it is in LA or New York. If you want to saturate the market with your product and put ads on all the TV stations, you can do that and afford to do it in Cedar Rapids. If you tried to do that in LA, you would go broke instantly. And so they use test markets to figure out how products work, and if it works there, then they'll start introducing it nationwide. By the way, the other 3, the 3 big test markets, one of them is Eastern Iowa, the others are Peoria, Illinois, and Columbus, Ohio. You know, so if anyone's looking at going to Ohio State, you're good to go too. But those would be our big test markets nationwide. So far we've had convenience, which is easy. We've had systematic, where mostly you number off. We ended up having a stratified sample where you choose from all the subgroups, and a cluster sample where one place usually is going to stand for everybody. And the last of the big 5 that we're going to talk about is what's called a random sample. And I will tell you, if you're going to put like a star beside anything in your notes, this would be the one to put the big star by, because it's going to be by far the most important. Before we get into what it is, though, I want to talk a little bit about what random isn't. You know that in everyday life, you'll see somebody that makes like some really stupid remark, and you sort of look at it and say, well, that was random. You know, that is a very common thing people do. That's not what random means in statistics. It doesn't mean weird or stupid or haphazard or something like that. In statistics, random is a good thing. And what random means in statistics is that everybody's got the exact same chance of being picked. If I wanted to pick a random sample of 2 people in this class, every one of you would have the same chance as everybody else of being picked. Now, sometimes people will hear that, and it goes on to say there's an organized way ahead of time that guarantees that it's fair. Sometimes people hear that and they will say, isn't that what you said about the systematic samples earlier? You know, that you decide ahead of time what you're going to do. The big difference is here, it's like you do it for each individual person, rather than deciding ahead of time it's going to be like every 10th person. Here it would be like, you know, I end up looking at Meredith and I flip a coin, heads you're in, tails you're out. And then I go on to the next person and I flip a coin. And then I go on to the next person and I flip a coin. And each individual time, it's got the exact same chance of being picked. You've got no clue before you start who's going to be in or who's going to be out. It's exactly the same level of fairness all along. Random samples are by far the best samples that you can do in statistics. And just thinking about it, yeah, you want everything to be as fair as possible when you do that. What that means is that you have by far the best chance that these are going to be a lot like the population as a whole. There are, however, always trade-offs in stats, and nothing is ever perfect. And it does turn out that random samples are almost always the hardest to gather. Not only can they be kind of a pain to gather, but they can also be rather expensive to gather the data on, which is why when you see random samples, it's usually like big business or the government that do random samples. And even then, it sometimes can be a waste of money. However, a lot of the theories that we're going to learn in statistics assume that you have a random sample, and sometimes they can kind of fall apart if you don't. So we'll talk about those a little bit later when we get to them. There are a lot of ways that you can get random samples. In problems I write, I will usually refer to some sort of game of chance, like rolling dice or flipping coins or that kind of thing. If you see that in a problem, it's a dead giveaway, it's a random sample. Your book loves the phrase random number table. You look something up in a random number table, and actually if you look in the back of your book, there literally is a table of random numbers there that you theoretically could use. What you do with that is it's like you go through the numbers and, you know, like the first person I look at and associate it with that first number, if that number is divisible by 5, she's part of my sample. This one it doesn't happen to be, so okay, I go on to the next person. Yeah, going down the column, that is divisible by 5. So you're it. You know, that's the idea of what I'm going to do with this. In the real world, nobody uses a random number table. What they do is they use technology instead. And you guys remember when I play bingo at Christmas time, I always use the random number feature on a calculator. It accomplishes the exact same thing, but it just does it with technology instead. There's all kinds of computer programs that'll accomplish that same thing too. And really, that's how things would be used these ways. So again, the key thing though is everybody's got the same chance of being picked. Now, like I said, your book is always going to assume that all of these are cut and dry. And there will always be something in the problem that tells you it's supposed to be this one. In the real world, though, people do overlap these all the time. One real common thing that's overlapped, for example, is what are called stratified random samples. This is the sort of thing they typically use in political polling. What they'll try and do is they subdivide the country into regions, sex, race, sometimes income levels, all the different ways you can think about. And then they try to choose random samples from each of those groups. So it's stratified and it's random. And you know, that does combine both of those features. But we're going to look at the different ones you have there and see what we come up with.